Hello everyone, welcome back to our OMICRON Test Universe series. In this video, we will explore the ramping module in the OMICRON Test Universe software. It's a powerful tool that allows us to automatically test the backup and the drop-off characteristic of protection relays. We will see how to set up ramp parameters, define triggers, and perform automated assessment to evaluate the relay performance efficiently and accurately. So let us dive in and see how the ramping module simplifies our protection testing. From the start page of the OMICRON Test Universe 5.00 Service Release 2, you can navigate to the test modules and tools, and then you can click on the ramping module as a standalone test modules to determine the threshold value, such as minimum backup and drop-off values of the overcurrent, and also the backup slash drop-off ratio, which called the reset ratio, and we can ramping up and ramping down the quantity, such as the magnitude or phase angle or frequency of the analog output and voltage signal. Otherwise, you can enter or click to create a new test document to have an automated and a customized test plan, as we will see right now. So from here, we can go to the Insert tab and or click Test Module. We can click the ramping to be inserted, or we can create it from a file. If we have a saved ramping module in a file, we can import it from a file. It will save your time by saving the data of test object details and hardware configuration. Then you can rename a meaningful name just to be understood in the test plan and also on the test report view. Then you can double click the ramping module. The ramping test modules automates the process of gradually increasing and decreasing the quantity of current and voltage values. And also, unlike the manual step ramp function in the Quick CMC module, this module allows the user to predefine the ramp shape and automatically record the results based on set measurements and tolerances. So it's mainly used to test the backup and the drop-off values of protection functions, such as the overcurrent, undercurrent, over and under voltage, and you can calculate the reset ratio by the ramping signals up to trigger a response, and then back down to observe the reset behavior. So to perform the ramping test for the backup and the drop-off values, there is a specific ramp parameters must be defined. This includes the start and the end value, the step size, and the step duration. For example, if I have an overcurrent stage 1 with a definite time overcurrent equal to 1.8 ampere, so with a tolerance 30% of tolerance, which means 54 milliampere, so we can define the step size by dividing this tolerance range into about 4 steps to give you a step size of roughly 14 milliamp. So the start and the end values also are typically set to 0.8 and 1.2 times the nominal value. So 0.8 multiplied by 1.8 will equal to 1.440 ampere, and 1.2 multiplied by the nominal value 1.8 ampere equal to 2.16 ampere. So each ramp step should last longer than the relay's operating time or the expected backup time. So if we are expecting the start contact to be instantaneously operating, so we can define the DT to be 100 milliseconds, which is long enough to detect the and evaluate the backup and drop-off values of the overcurrent stage. Also, we can define the delta here to be 14 milliamp, as we explained. And also we can add a ramp 2 to make the drop-off test. We can add ramp2 to simulate the drop-off test, and we will start with 1.2 times the nominal value, which equal to 2.16 amp, up to 0.8 from the nominal value, and also the delta, which is the step size, will be in minus because we are decreasing the current values, which means ramping down the current value, so it will be a decrement, so it can be minus 14 milliamp with the same DT. So here is the quantity also and the ramp status. So we have a set mode. So this set mode can be defined to be a direct or line-to-line or symmetrical components or power or fault values using the fault calculator, or impedance using 3 modes with a constant current, with a constant voltage, and with a constant source impedance. And also it can be relative as a per unit values based on the line length. So here is the standard view in the ramping test module with a various different window views. So we have here the test view, we have here the signal view. It can be a signal view or a phasor view for the analog current and voltage signals. It can be impedance view if we are ramping up or ramping down the impedance in case of a distance protection or power swing protection. And also we have the report view. We will walk through these views, and we have also the ramp assessment to define the assessment of the overcurrent test for the pickup and the drop-off values. We have also a calculated assessment to calculate the reset ratio, which is called drop-off over the pickup value, which is supposed to be greater than 95%, and you can define the calculation here to be division or a percentage or any kind of calculation you need to calculate a third value from a two measured value. So we have here the set mode and the fault type, so you can define the type of the signal to be ramped, and also the available options are the same as those options in the quick CMC test module. This means that in addition to the current and the voltage, we have also symmetrical component, we have voltage fault values, we have impedances, and we have powers which can be ramped up or ramped down directly. And what exactly the ramp is to change is set under the signal and the quantity. Okay, so we have two different signals can be ramped at the same time, signal 1 and signal 2, such as the power swing. We need to simulate dV by dt, and in the same time we need to simulate di by dt to simulate the impedance trajectory from the normal loading area up to the impedance characteristic. We have also the start and the end values, as we explained, of the signal to be ramped up and ramped down can be entered here. We have also the step size, which is the magnitude by which the signal is to change with each step. You can also set the output duration of the step here, which is the dt, and it always must be longer than the operating time of the protection relay. So this ensures that the protection relay will respond before the end of the step, which triggered it. The setting also result in a change rate and a step count, and the time duration can be shown here. So we have in ramp 1 we have a total of 53 steps, and the time of ramp 1 will be 5.3 seconds, and the same also for ramp 2, which means the estimated test time will be 10.6 seconds. And here is the stop condition to be defined to detect the pickup value and the drop-off value by using the start condition. So in ramp 1 we are expecting the pickup value, so the start binary input will be changed from 0 to 1. On the other hand, in ramp 2 the start will change from 1 to 0, and this also we can be defined here in the trigger button. So every ramp can be assigned to a stop condition. So as soon as this event occurs, the next ramp will start on the or the test will be finished. So this means that the set end value is not actually reached. This stop condition is configured in the detailed view. And also using the ramp tab to insert a ramp states. This tab also includes the ramp navigation toolbar, as you can see from here. So you can insert a ramp after or a ramp before, or you can append a ramp. And here is the ramp assessment, as you can see from our screen here. You can see the ramp assessment, and you can give it a name, just a meaningful name to be clear for everyone, using the same test plan or reading the test report. And here the assessment number 1 for the pickup value will be related to the ramp 1, and the trigger condition will be the start contact from 0 to 1, and now the signal will be automatically chosen from here. So now I'm choosing IL1. You can choose line to line or 3 line. You have multiple fault types, and also you can choose the quantity to be ramped up or ramped down, such as the magnitude, phase, and frequency of IL1. In the detailed view, we have also analog output, as you can see here. So this analog output used to define the signal parameters that are not ramped, such as the phase angles or frequency, while the ramped quantity, such as the magnitude, remains fixed as previously defined. So as you can see here, the IL1 is in gray color, which means this signal is used for ramping up and ramping down, while the IL2 and IL3 fixed to 0. We have also the binary output. We can allow this binary output tab allows the configuration of binary outputs that may need to operate during the test to simulate any kind of event to the protection relay binary input. And since we don't have any binary output need to be simulated, so we are just if you need to simulate any kind of binary output to simulate a special event to the protection relay binary input, you can go to the global hardware configuration and configure the binary output just to be used in the local hardware configuration. Just you can add a terminal and give it a name, such as binary output. number 1, and you can also specify the connection terminal. And then when you go back to the ramping module in the binary output module, you will find out this binary output is available. Just you have to make sure that the local hardware configuration have the same configuration of the binary output as you can see from here. So we can give it a name like binary output number 1. And then you will find out this binary output here, so we can close or open, so to control this binary output and to simulate a special event to the protection relay binary input, such as the circuit breaker close command or circuit breaker status on or off, and so on. Then we have the trigger tab. This trigger tab lets you to set a stop condition for each ramp. So without it, the ramp will run until the end value. So typically for the overcurrent protection relay, the binary trigger is used here, where the backup signal stops the up ramp and its drop off stops the down ramp. So the multiple signals can be combined using the AND or logic. If you have a multiple binary inputs here, you can define the trigger logic between both of them. Also, it can be none if you don't have any stop conditions to be triggered, or you can also specify as key pressed, and then you can define the instruction to write any instruction for the user, as you can see from here. Then after clicking, it will assess the ramp and it will go directly for the ramp 2. Now we are talking about IL1 pickup and drop off overcurrent function, but for the two-phase fault, it's important to set the phase angle between the faulty phases to be 180 degrees to ensure a realistic current simulation, and each ramp must be configured separately in the detail view with the ramp navigation toolbar to help you track and select which ramp is being edited. Here is the signal view, which in the ramping module, to visually display how the ramped analog variables and how binary triggers changes over time, and allowing you to observe the test progression and triggering behavior. When impedance is being ramped, also it can be shown here and displayed here in the impedance view. So the impedance view shows the path relative to the defined distance protection zone. So this is not used in the current example. Similarly, the phasor view also. The phasor view will present the signal as vector diagrams and illustrating their phase relationships. Here is the ramp assessment and the calculated assessment section to handle the automatic evaluation of the ramp test results. So in the ramp assessment tab, the measurements are defined to determine both the pickup and the drop-off value. For example, during the ramp 1, the pickup value with set point equal to 1.8 ampere, and the allowed deviation, as you can see from here, to be 3% from the expected value. So for ramp 1 it will be 54 milliampere plus or minus, and for ramp 2 will be 51 milliampere plus or minus with respect to the drop-off value, which is 95% of the set point of the pickup value. And also in the calculated assessment here, you can find out the reset ratio, which is automatically calculated using the drop off and the pickup value as an input. So we can choose any algorithm here like x over y or x over y as a percentage with a set point equal to 0.95, and the accepted deviation of 0.05 plus or minus to ensure a precise evaluation of the relay performance. Then you can click start and continue button to start the test, and the ramp will run until the stop conditions, and the measurement and calculation are taken and made automatically. So this test is then assessed, and a green check mark indicates the test successful, and the red cross means that the test failed. So let us start our practical example. So as you can see, here is the pyramided shape of the ramp 1 and ramp 2, which means ramping up the current and ramping down the current. And here is the start condition. So it changed from 0 to 1 at this value, and then it changed from 1 to 0 at this value. So you can see the ramp assessment from the assessment view. So the actual value is 1.804 amp, which means the deviation is 4 milliamp, and here is a green check mark indicates that the test is passed. In the same way, also you can see the drop-off values. Then you can see the calculated assessment, which is calculated based on the drop-off and the pickup actual values. And here is the actual reset ratio is equal to 0.9568, which means is accepted, depends on the allowed deviation and allowed tolerance bands. Also, we can do the same also for the line-to-line, and as we explained, you have to make sure that the phase shift between the faulted phase lines should be 180 degree, as you can see from here. And here is the gray color, means that we are using the IL2 and IL3 to ramp up and ramp down the magnitude of the current values. So it's in gray color. And we have here also another option called the force absolute phases. So force absolute phases, with this feature, if we the force absolute phases is disabled, this means in order to prevent the phase jumps, the ramping adds actual phase angle values at the moment the execution of ramp 1 is stopped to the user-defined start values of the succeeding ramp 2. But if you make enable for this feature, with feature force absolute phase enabled, so the ramp will start with the absolute phase angles, which means the user-defined values. So regardless of the actual phase angle values of the preceding ramp. We can also start our phase-to-phase IL2, IL3 overcurrent pickup and drop off. As you can see, here is the result right now. Here is the pyramidal shape of the IL2 and IL3, and you can see the result of the actual pickup and actual drop-off values, and also the actual reset ratio, which is calculated from the actual pickup and drop-off values. You can do the same also for the 3 line. As you can see here, the signal one is IL1, IL2, IL3, and we are controlling the magnitude of IL1, IL2, IL3 in the gray color. And also you can link these values to be linked to the expected value. So the I greater is equal to 1.8 ampere. So we can define the start value to be 80% from this value, and also the end value to be linked to the same nominal value with 1.2 multiplied by the nominal value, which equal to 2.16, just to have an automated test plan. Values will be automatically adapted to the new parameter setting. If you have any change in the relay parameter setting, it will be automatically adapted to the new test value without any need for the manual interference. Also, you can define or you can link these values for the delta, which is the step size, or the dt, the delta time, and also you can link the expected nominal values in the ramp assessment. So we are expecting 1.8 ampere here, so we can link to x ray. We can also link to the deviation. As you can see, the current tolerance in amperes, which is equal to 3% multiplied by the nominal value, equal to 54 milliampere, plus or minus. And you can do the same also for the drop-off values and the calculated assessment. Then you can click Start. So here is the result, as you can see. You can control also the report view as you like. So we can click report setting and define, and we can remove the test setting and test module just to make it short as enough. Thank you.